In this lecture, we're going to cover Unit 7, Acquisition 2 on dilutions. So first, a term to be familiar with is a stock solution. Concentrated solutions are called stock solutions. So in our lab, we buy very concentrated solutions, and then if we need them to have a different molarity, we can dilute them down. So you're going to see questions where it tells you we have a 12 molar stock solution, and let's say we want to dilute it down to a 1 molar concentration. So that highly concentrated solution is called a stock solution. So what is a dilution? A dilution is the process of lowering the concentration of an aqueous solution by adding water. So that should make sense. If we have a highly concentrated solution and we want to dilute it, we want to lower the concentration, we could add more water. Think about if you've ever made like lemonade or Kool-Aid, anything with a powder, and it was too concentrated. To dilute it, you would add more water. So the equation that we use is M1 V1 is equal to M2 V2, where M stands for molarity and V stands for volume. So if we take molarity times volume of our initial solution instead of equal to molarity times volume of the second solution, we should be able to solve for any of these variables. One thing to be mindful of when we're doing dilution calculations, the initial and final volume must be in the same units. So if your initial volume is milliliters, your final volume has to be milliliters. If your initial volume is liters, the final has to be liters. Those need to be the same. All right, let's get right to the math. Let's say you were asked how many liters of a 2.0 molar solution would be needed to make 1.5 liters of a 0.50 molar solution. So in this case, we have a 2 molar solution, and we want to dilute it down to a 0.5 molar solution. The only mistake that I see students really make when we're doing dilution calculations is not putting the correct molarity and volume together. Of A is like your giveaway that those two values go together. I want to make 1.5 liters of a 0.5 molar solution. It does not matter whether you make this M1V1 or M2V2 as long as they're on the same side of the equation. So let's say M1 is 0.5 molar and V1 1.5 liters. We want to know how many liters of a 2 molar solution we need. So that means M2 would be 2.0 molar, and V2 is what we're solving for. Once you have your variables defined, it's just going to be plug and chug. M1 times V1 is equal to M2 times V2. Now we can put this in our calculator and solve for the missing variable. I get 0.375. And then don't forget our last two things we have to do for every calculation. First, we want to round to the appropriate number of significant figures. Every measurement has 2 significant figures, so my answer can have 2 significant figures. Leading zeros are not significant, so I would round up to 0.38. And lastly, we need a unit. We were solving for liters. 0.38 liters would be my final answer. Let's try one more. How many milliliters of a 12 molar hydrochloric acid stock solution would be needed to make 250 milliliters of a 1.0 molar solution? So this is something that I do all the time. Like I said, in our lab, in our storeroom, we buy concentrated stock solutions. We use 1 molar hydrochloric acid a lot. So this is the calculation that I'm constantly doing to figure out how am I going to dilute this solution to go down from 12 molar to 1 molar. So let's start by defining our variables. Remember, of A is your key, that volume and molarity goes together. So I have 250 milliliters of a 1 molar solution. Those two values go together. Again, does not matter if you make them M1V1 or M2V2, as long as they're on the same side of the equation. Again, of A is your key that those go together. Milliliters of a 12 molar solution. That means M2 is 12 molar. We're solving for milliliters, so that will be V2. Plug and chug. M1 times V1 is equal to M2 times V2. So let's put this in our calculator. I get 20.83 repeating. And then last two things that we do for every single calculation. First, we need to round to the appropriate number of significant figures. Look at all 3 measurements. 12 molar has 2 significant figures. 250 has 2 significant figures. Trailing zeros without a decimal are not significant. 1.0 has 2 significant figures. Trailing zeros after a decimal are significant. Every measurement has 2 significant figures, so my answer can have 2 significant figures. And then don't forget units. So final answer, we would only need 21 milliliters of our 12 molar stock solution. The rest we would add water, and that would dilute our solution.